Hello everyone, welcome to the first part of the IA review. There are 36 questions in your review packet, and this video will cover the first 12. So to start off, there is a mix of calculations and conceptual questions. For the calculation questions, I recommend that you guys follow this problem-solving strategy. I may have repeated it before, but it's always good to remember, review. So take a look at these 4 steps. They should help you to identify which equation to use in your reference table and solve your calculation questions. Let's begin. Okay, so number 1 asks, a 25 Newton weight falls freely from rest from the roof of a building. What is the total distance the weight falls in the first 1 second? So we always gotta list our variables. But it's also important to notice here that this is a free fall problem, falls freely from rest. Okay, so we're already given some important pieces of information. Our initial velocity is 0 meters per second. Our acceleration, 9.8 meters per second squared. We have a time of 1 second, and we're looking for our distance. Looking at the equations in the reference table, you should use this equation. Because our initial velocity is 0, this crosses off, and we're left with d is equal to 1/2 9.8 meters per second squared times 1 second squared. And the answer you should get is choice C, 4.9 meters. Okay. Number 2. A 1 kilogram ball is dropped from the roof of a building 40 meters tall. What is the approximate time of the fall? Once again, this is another free fall problem. So we'll show the work for number 2 over here. We can ignore the mass here since this is a free fall problem. This time we have a height of 40 meters. Our VI is still once again 0 meters per second. And our acceleration is still 9.8 meters per second squared. This time we're looking for the time. We can still use the same equation. So d is equal to VIT plus 1/2 AT squared. VI is 0, this crosses off to 0. And we're left with 40 meters is equal to 1/2 9.8 meters per second squared times t squared, which we're going to look for. And the answer to that question, after you plug it all in and calculate, is choice A, 2.9 seconds. Okay. Number 3 is another free fall problem, but this time we have a horizontal velocity given here. Once again, you guys should remember that horizontal motion does not affect the vertical motion. So we're going to treat this vertical motion problem as a free fall problem. Okay, number 3. We're looking for the time in this problem. Just like the previous 2, we use the same exact equation. once you solve for t. Whoa. Okay, so the choice you should obtain is choice A, 3.19 seconds. Questions 4 and 5 are based on this little prompt. So we have two projectiles launched at different horizontal speeds, and they're dropped from the same route, same cliff of the same height. And first we gotta figure out how high is the cliff. Given that we're looking for the height of the cliff, this is a vertical distance, so we disregard all the horizontal speeds we're given. Okay. So in our y direction, we're always going to have a vertical acceleration of 9.8 meters per second squared. Our initial velocity in the y is always 0 meters per second. We're looking for d. And it says, at least for projectile A, it drops from the cliff and it reaches the ground at 3 seconds. So it falls for 3 seconds before hitting the ground, so that time is 3 seconds. We're going to use the same equation we've been working with before. And the distance you should get is 44 meters. Choice B. Now we're going to see how much time it takes for projectile B to reach the same surface. And regardless of their horizontal speeds, they should reach the ground at the same exact time because they're falling from the same exact height. So the answer for this is choice C, 3 seconds. Now we're going to move to the other side for question 6. Question 6 shows this diagram with a cannon shooting a ball with initial horizontal speed of 250 meters per second. Sorry. The question is asking which action would most likely increase the time of flight of a ball fired by the cannon. So, let's list some of the things that would increase airtime. So if we want to increase our airtime, there are two things that could happen. Increase our angle, or increase our height. And looking at our choices, the only choice that fits that is choice C, positioning the cannon higher above the ground. That increases the height from which it falls, therefore more height, more airtime. Question 7 has a plane flying horizontally with a speed of 100 meters per second, then it drops a crate. The crate is still going to carry that same 100 meters per second horizontally. And so what we know about horizontal motion, the horizontal velocity stays constant throughout. So if it starts out with 100 meters per second, it's going to fall still with a speed of 100 meters per second horizontally. Choice B. Question 8 has an archer firing two arrows at two different angles with the same force, so they can have the same speed. What's different about the angles is that it's going to have different flight times and different ranges. So what we know about the 45-degree angle, 45 degrees is a special angle. This is where we have the max range. Whereas angles going towards 90 degrees, we have increase in airtime and height. Okay, so compared to the arrow fired at 60 degrees, the arrow fired at 45 degrees is going to have more range. So we can cross those off. And it's going to have shorter airtime, shorter flight time than the 60 degrees arrow. So that's choice C. Number 9 has a velocity of 19 meters per second at an angle of 60 degrees above the horizontal. So we just got to find those components, x and y. Our x component is the horizontal, so we use cosine. Oops. Okay. So remember, the angle goes inside the trig function here. Our Vy, our vertical component, uses the sine function. And the one that fits these answers is choice B. 13 meters per second vertical and 7.5 meters per second horizontal. Question 10 has a projectile launched at an angle 60 degrees above the horizontal at initial speed of 40 meters per second at that angle. Okay, so the question asks which graph best represents the horizontal speed of the projectile as a function of time. If you guys think back to the concepts we learned in 2D motion, the horizontal speed of a projectile stays constant over time. So Vx always stays constant. And let me stress that with some exclamation marks and some underlines. If we look at our choices, the only graph that shows that is choice D. Question 11, a ball is thrown with an initial speed of 10 meters per second. Which angle should the ball be thrown to reach the greatest height? So once again, which angle gives us the max airtime and height? That is indeed 90 degrees. Gives us max airtime and height. And let's put up the other angles as reference. 45 degrees gives us max range. And 0 degrees gives us max horizontal speed. Okay, so it's choice D, everyone. Choice D, 90 degrees. Now the last question for this part 1 video, which object has the greatest inertia? Inertia is related to what other quantity? Mass. So if inertia goes up, so does the mass. So the greatest inertia is the object with the most mass. And the only one that fits that is choice D. We could ignore all the other velocity values there. All that matters is the mass. And that is it for part 1. Stay tuned for part 2.